All right. So I just want to inform everybody that this session is recorded. So if you missed something important here in my session today, you can actually check it out this one in our completed section. All right. So for today's session, I will be discussing about mathematical induction. All right. So we are already done with the concept of sequence, series, how to identify arithmetic and geometric sequence, and also the sum of that. Okay, so now let's proceed here. Please allow me to introduce the topic that we have today, which is all about mathematical induction. Okay, so what is mathematical induction? Okay, as you can see here, okay, a type of proof that deserves special attention is what we call mathematical induction. All right. So some of the statements of theorems which can be proved using mathematical induction involve an integer variable. Okay. So later we will know the one of the examples, okay, for finding the or formulating the formula, okay, given the summation. Say, for example, for the series, okay, or a sequence, say, for example, okay, for finding the summation of, say, for example, an infinite number, okay. So this actually one of the ways, okay, to prove that that equation or that formula is actually true, okay, using mathematical induction, okay. So we have here an example, as what I said, an example of such a theorem, which is, as you can see here, if we're going to, to get the sum of the counting numbers and infinite counting numbers up to n, 1 plus 2 plus 3 up to n, okay, which is an infinite. So it's stated here, this is only a theorem, okay, that for finding the sum of that, okay, counting infinite numbers, we have here the given formula to find that. Okay, so we have here n times quantity n plus 1 all over 2. Okay, so this is only a theorem wherein your 1 plus 2 plus 3 up to the infinite will be like this. Okay, so but how are we going to prove that this is actually a true statement? Okay, so using mathematical induction we can actually prove that one. Okay, so the good thing about induction is that it allows a theorem to be proven through where an infinite number of cases exists without exploring each case individually. Okay, so this is actually one of the essence of mathematical induction. Okay, so as what is stated here, the principle of mathematical induction states that let S of n be statement involving the positive integer n. Okay, so if your S of 1 here is true, okay, so this will be the basic case. If S of 1 is true, and for every positive integer k, okay, the truth of S sub k implies the truth of S sub k plus 1. So they are related. If that is true, if your S sub k is true, then we should say that S k plus 1 is something like true also. Okay, so again, S sub k implies the truth of S sub k plus 1, then the statement S sub n must be true for all positive integers n. Okay, so we have actually conditions for that for you to understand more. Okay, so say for example, when the when the first domino falls into it, okay, so it will hit the second one. So that's the concept. Now, if each domino will hit the next one and each domino that is hit will fall, then logically speaking, we would now realize that the complete line of dominoes will fall. So it's important to show that the verification step and the inductive step in the principle are satisfied. So the conditions must be satisfied, okay, for in order for us to do the mathematical induction. Okay, so as what I said, this principle of mathematical induction is comparable to an infinite line of dominoes. Okay, so the inductive part of the principle would say that the domino in the n plus 1 position falls whenever the nth domino falls. Okay, so there's a something like domino effect there. So that will be the concept, okay, in proving mathematical induction. Okay, so in doing so, using that domino effect, we can actually, lead to the steps of mathematical induction. So let us be a conjecture involving a positive integer n. So let's say that s is true for all positive integers. Okay, so we are assuming that your s is true for all positive integers if the following conditions hold. Okay, so this three is actually the steps of mathematical induction. So let's say, as what I stated earlier, we have here the basic case wherein if your P of 1 is true for n equals 1, so that will be the basic case, then therefore, we can actually, proceed to the next step of mathematical induction, which is if your S is true for n equals k, then therefore your S is true for n equals k plus 1. Okay, so later we will know the process, okay, using mathematical induction. All right, so for you to understand more, I have here an example, but I want you to be familiarized with the steps of mathematical induction. Okay? All right, so on the next slide, we have here to give an example. So we are asked to prove by mathematical induction that the sum of the first n positive integers is given by the formula like this. Okay, so this will be the formula, and we are actually proving using mathematical induction that this summation is actually equal to this formula, which is n times n plus 1 all over 2. So how to do that? Okay, how to do that? So we have here the summation of I from I equals 1 up to n, and we are proving that this will be the formula. Okay? So in doing so, if we're going to, expand this, this is I, and this is up to infinity, right? So starting from 1, so we have here 1 plus, we are looking for the summation since this is a sigma notation, right? So 1 plus 2 plus 3 plus this one up to infinity, and this will be the formula. How to prove that? Okay, so only have to do is, of course, you have to follow the given steps. Okay, for the first one, for verification, let us verify that when n equals 1, so let us prove. Okay, let us prove that if n is equal to 1, then therefore your s sub n or your s sub 1 is equal to 1 also. So let us see. Okay, so this will be the basic case in proving. Okay, so that is for the step 1. So all you have to do is you have to follow the formula. Okay, so your n is the number of term you have. So for example, we have your 1, okay, as your p of 1. Let us know if it is true or false. Okay, so if that is true, so we can actually proceed to the step 2. Here po. So we have here n. Your n is equal to 1. So we have your 1. We are proving for this. Okay. Dapat po 1 po ang sagot. Okay. Equals 1. Your n is equal. You just need to plug in. Okay. So 1 quantity 1 plus 1. Since you have your n plus 1. Okay. All over 2. And we all know that 1 plus 1 is equal to 2. And if you're going to multiply that 1 into 1, you will be having 2. Okay, so 2 divided by 2, you will be having 1. Okay, so that is correct. So it sets the condition for step 1. So let's say that your n is equal to 2. So let us try. But then if this is now correct, so you can now actually, proceed to step 2. But let us prove by the different number or for the next number of terms you have. Okay, so we have here, say for example, n equals 2. Okay, so n equals 2. So we are actually looking for the summation of the two terms, which is 1 plus 2 dapat po 3. Okay, so let us see if it is 3 or not. Okay, so we have here 3 equals your n now is equal to 2. So we are actually using the second term. Okay, so 2 times the quantity of 2 plus 1 all over 2. So in simplifying, okay, as you can see here, 2 plus 1, that is 3. And 3 times 2, that is 6. And if you're going to divide 6 divided by 2, that is 3. So it's a fact. Okay, so we can now actually satisfied the step 1. So if that's so, we can now actually proceed to step 2, which is all about induction hypothesis. Okay, so for step 2, we are actually assuming that the formula is true, right? For n equals k. So all you have to do here is you just need to substitute the value of your n as k. Okay, since we already done with step 1, which is true. Okay, so we can now proceed for step 2. So all you have to do, as you can see here, we have here the given. Okay, so lahat po ng n, let us substitute that one as k. Okay, so as you can see here, s sub k, your n here. Okay, so that will become k equals 1 plus 2 plus 3 plus k. Okay, this 1 plus k is equal to, as you can see here, times n plus 1 all over 2. You will be having k, quantity k plus 1 all over 2. As you can see, ang naiba lang po will be your k. Okay? So same pa rin po. Let's just only say that your n is equal to k. So that is for step 2. Okay, so since this is true for induction hypothesis for number step 2, so we're gonna actually prove for step 3 using or for letting us, n as equal k plus 1. Okay, so let us prove the induction. Okay, so we need to show, this will be the concept, we need to show that this one is actually equivalent to this one. Okay, to really prove that this this formula, ito pong given na to, is true. Okay, so we have to show that this one is equivalent to each other. So how to do that? Of course, you just need to substitute n as k plus 1. So we have to add k plus 1 into here. Okay, so let us add k plus 1 here. How to do that? So since you have now your s sub k, and we need to, add only k plus 1. So all you have to do here, so let's just only copy the given, and we have to add k plus 1 or a sub k plus 1. In doing so, as you can see here, so we just need to copy that one, this one, because we are now looking for the s sub k plus 1. Okay, so you will be having here 1 plus 2 plus 3 plus k, and we have to add k plus 1. Okay, so for this scenario, we have to substitute k plus 1 into n. Okay, so this time around, your n is equal now to k plus 1. Okay, so let's go back to the formula that is being, proved here. Okay, so we have here n times n plus 1 all over what? N times n plus 1 all over 2. So this is the formula that we are trying to prove, right? So since we are now in step 3, you just need to substitute only n as equal to k plus 1. Okay, so your n here, we have your x plus 1 now, and your n here will be x plus 1 plus 1. Okay, that's why we have here quantity k plus 1 times k plus 1 plus 1 all over 2. Okay, so in doing so, so we all know that this one, okay, we all know that 1 plus 2 plus 3 plus k is actually equal to k k times k plus 1 all over 2. Okay, so ito po ay equivalent po dito po. Okay? So in simplifying, this one is actually equivalent to this. Okay, so we just need to substitute only. And your k plus 1, copy only, plus k plus 1 equals this one, copy. So 1 plus 1 is actually equal to 2. Okay? So as you can see here, we have here the denominator, which is 2 and 1. So all you have to do is you have to find the less common denominator, okay, which is 2. So we all know that 2 quantity k plus 1 all over 2 is actually equal to what? K plus 1. Okay, so naparehas lang po yung LCD. So cancel out na yan, okay, as you can see, right? But then let us simplify that one. To simplify with, you have your k times k, which is k squared, and k times 1, you have here k, okay? And since we have now denominator, we can now, the same denominator, we can now actually combine that one, okay? So 2 times k, that is plus 2k, and then 2 times 1, that is equal to plus 2. So combine like terms, k plus 2k, you have here 3k, okay? And we have here plus 2. So we have to copy plus 2. All over 2 equals, if we're going to simplify this one, okay, So using FOIL method, you can actually use that method. So k times k, you will be having k squared, and k times 2, you have here 2k. And for the inner, 1 times k, that is positive k, and 1 times 2, okay, the last term, you will be having positive 2. So if you're going to combine that one, you will be having 3k here, okay, plus 2, copy only. So as you can see here, we showed here, okay, we show here the process that that s sub k, okay, which is true, is actually equivalent to you know s sub k plus 1, okay, if you're going to add that one. So as you can see here, this is correct. Okay, so we prove here na kung saan they are equal to each other. Okay, so if you're going to simplify this one, you will come up with the same also. Okay, so as you can see here, k plus 1, okay, this is k plus 2, so you just need to what? You just need to simplify only this one, and you will come up with k squared plus 3k plus 2 all over 2 equals k squared plus 3k plus 2 all over 2. So if you already done with step 3, then we should say, in conclusion, since both steps have been validated, okay, using step 1, step 2, and step 3, the basic case and the inductive case, using mathematical induction, okay. So since both steps have been validated, given the statement is true for all positive integers, so we have proven that this summation of I from I equals 1 up to n is actually equal to n quantity n plus 1 all over 2. Okay? So did you get it? Do you have questions on that?